Assalamu alaikum, dear guys. My name is Mohammed Gashuddin. Welcome to the GFC school. Guys, now I'll discuss CP greater than CV. Here, that means CP minus CV equal to R. This I will prove now. Okay, I will show CP minus CV. Guys, I have to show CP minus CV equal to R. How can I prove this? Very simple, guys. It's a heat and thermodynamics related equation which I have to show now. Very simple. For showing this, I'll take a piston which is frictionless. Okay, and actually we'll take a cylinder, and there I will use a piston which is frictionless. Okay, and I will use gas of 1 mole. As you know all, there are three states of matter. One is liquid, solid, and gases. Here we'll use the gaseous state. That's why here we'll consider pressure, volume, etc. etc. Guys, for proving this, we have to know some basic formula, which are those. Okay, guys. Here CP minus CV. If here, what do you mean by CP? CV. CV here, specific molar gas constant due to constant pressure. Specific molar gas constant that is due to constant volume. And for this, we have to consider some equation as you know this is actually thermodynamic process. That's why we have to provide heat. If we provide heat, then we know that is done our work. And guys, here CV means, sorry, CV means specific heat at constant volume. Since here volume is constant, guys, when volume is constant, then work done d W equal to 0. Since volume is constant, work done is 0. And guys, we know what do you know? CV, change of temperature, equal to du. This is actually one equation which we have to know. And guys, sorry, CV due to constant CV, or could say dk equal to dv dt. dk equal to CV dt. Here temperature change, and here heat change, and this is specific heat due to volume. This equation we have to know and we have to understand. Guys, from the thermodynamic first law, we know what do you know? dq equal to du, or we can write such a del q equal to del u plus p del v. This is actually work, and since work is 0 due to constant volume, that's why we could say del q equal to del u, and this is 0. From this relation, we have said this. Okay. Now, let me do this. That's why we could say the first law of thermodynamics. What is the first law? dq equal to del u plus P del V. Here del. Okay. Del Q equal to del Q plus P del V. And just now I've said due to constant volume work zero. So we got this correlation. So we could say del U equal to CV, sorry, del T. Okay, just now I've written del Q equal to CV del T. And since volume here is constant, so W equal to 0. And we know thermodynamic first law. This is a first law of thermodynamics. Okay, thermodynamics first law. And from this first law, we have got this correlation. As now, here we have to know del U is energy, internal energy of the system. Okay, and we could say change of internal energy. Last day, in my first class, I said what is internal energy. Guys, when we apply heat, then in the system, the internal energy will be changed, and that is the internal. And I gave an example. If you take a pot in the kitchen and take some water in the pot, and if you provide heat, you can see the system of the pot, the volume of the system of the pot will be changed due to heat, and internal energy of the system in the pot will be changed. That is internal energy. Guys, here this relation we got. Okay, fine. Now again, if we just now we have taken constant volume. If you take a constant pressure, what will get? Cp here now. Cp here specific heat due to constant pressure. Right? Okay, fine. This correlation we can say, what can we say? We can say del Q equal to Cp change of temperature. This correlation also we can draw. Okay, this correlation we can draw. That means two relation we got. One is del U equal to Cv del T, another del Q equal to Cp del T. This actually the two correlation will be needed for proving Cp minus Cv equal to I. Guys, here we got del U equal to this and del Q this. Now we know the first law of thermodynamics. This first law of thermodynamics. Again, I will apply first law of thermodynamics. Del Q equal to del Q plus P del V. Here, guys, this is the change of volume and this is the concentration. And guys, this is the change of internal energy and this is the change of provided heat. Now we'll put del Q into Cp, change of temperature, del we've got Cv del T plus P del V. Nice. This correlation we've got. Okay, Cp del T into Cv del T plus P del V. Okay, fine. Now we know the ideal gas equation. But do you know ideal gas equation? Do you know Which one is ideal gas equation? I know because this is like this. PV equal to RT. This is ideal gas equation. Guys, since we've provided heat, that means there will be created volume change and temperature change. Guys, that's why we could write like this way. P V del V into R del T. This we can write down. But anyway, since T, sorry, T plus del T. Here, first we had volume V, first we had temperature T. When we provided heat, then temperature changes, volume changes. Right? Now we could write PV plus P del V equal to RT plus R del T. Okay, fine, fine. This and this equal. That's why we could say P del V equal to R del T. Guys, look at that down. This is equation 1. Now, if we put this relation in the equation 1, then what can we say? What can we say? Guys, yeah, okay, let me read this section. Nice, Cp del T equal to Cv del T. Just now we got P del V equal to R del T. That's why you can put this equal to this plus R del T equal to, since here del T, okay, you can cancel out this. Finally, we got Cp equal to Cv plus R. Now we can write Cp minus Cv equal to R. Guys, finally, we got our required line, which is Cp minus Cv equal to R. That means we can conclude here Cp is greater than Cv, which difference is equal to molar gas constant. That means we can say Cp always greater than Cv. This is our record line, which I have shown, and finally I have shown Cp greater than Cv. That's all today. Salam.